Hello, everybody. Welcome to Bursa webinar that is titled The Future of Automotive Semiconductors. Okay, so my name is Shen Chu. I'm the moderator for this webinar, and we meet again on this webinar brought to you by Bursa Malaysia and managed by LiveChamp. So today we are very excited because we are going to delve deeper into this sector that I think appeals to many of you today. We also received overwhelming registrations response, so we were so encouraged by that. So today we're going to go deeper into the automotive sector and see which semiconductors can benefit from this trend. All right. So before we begin, just want to state the disclaimer again. So whatever we share on this webinar is only for educational purpose. In no way that give any buy or sell recommendation to any company, case study that we cover in this session. So no any buy call, sell call for any company. So if you decide to buy or sell any companies from this seminar webinar, you do it at your own risk. Now today, due to popular demand, we are bringing back David for a third sessions on this segment, which is automotive semiconductor. Allow me to introduce him again. So he is an engineer by training. So David began his career as an engineer in the telecommunications industry for 10 years before turning to his passion in value investing. He served as director in a local equities education and research firm for 3 years, managing research efforts and delivering advanced value investing and portfolio management education series. Thereafter, he stepped out to pursue his own aspirations, establishing the Spiral Thinker Group, a collaborative alliance to promote intelligent value investing and develop algorithm-based adaptive portfolio strategies for sustainable long-term wealth creation. Now, David is now a full-time investor and dedicates his time and resources to nurture the youth in financial literacy. He's often invited to speak in broker seminars, webinars, as well as other Bursa endorsed events, and his professional comments and opinions on value investing are featured in business publications like Focus Malaysia. So David also provides consultation services in value investing and advanced portfolio strategies for high net worth individuals. So isn't his profile impressive? Now, if you're tuning into David's previous two seminars, like usual, this session, I believe that he's going to blow your mind away. Okay, so without further ado, let me hand over the session to you, David.
All right, Shane. You're passing over. Yeah, I got it. So can you guys see my screen? Yeah. All right. Good evening, everyone. It's good to be here again. Nice to see you guys. Although I wish I could see some of you on the other end. Thanks very much to Bursa Malaysia as well as LiveChamp for getting me back here to talk about something which is very passionate for me. But before I start, a couple of things I want to just share with you guys. First of all, the content which I will be presenting tonight is not just by myself alone. It is actually a collaborative effort of all my the members in the Spiral Thinker group who comes from different background, but our core competency is in technology, right? So that's why you see that I really love to talk about technology, so much so that Malaysia is an important player in the global semiconductor scene. Secondly, I will for as a disclaimer, sorry about that. Today, tongue got tired very easily. This is not a recommendation to buy, hold, or sell. Basically, we are just sharing what we know about the particular topic. Yeah. Since this is the third installment of the semiconductor series, so I've asked Shane to share with me the feedback from the previous sessions. So we got back and to go back to the drawing board because we felt that perhaps the previous session was a bit too technical, a lot of formula that may have scared you away. So in this round, hopefully we are better now. All right, you'll be the judge later. We have simplified our presentation as well as tried to reduce the number of slides so that we give more time for Q&A later. Yeah, so we hear you. I will do my best. All right, to be a better speaker. Okay, so without much further ado, Let me just see if I can do this. Pointer mode, highlighter. No. Okay, got great. Now, without much further ado, let's start. Yeah, how come I this? Okay, never mind. Okay, now today the agenda would be a couple of things here. First, we're going to talk about the future trends in automotive industry. Okay, followed by the paradigm shift, in automotive electronics because of this change in trends. Now, next, the three topics, it's not going to be in this chronological order. Basically, it's a little bit of mix and match. So I'm going to talk about the three key growth areas of the automotive electronics, yeah? And then at the same time, I'm going to introduce who are the major players globally, mostly from the US, that how we tie it back, because there are a lot of Malaysian listed technology companies or semiconductor companies that are involved in the supply chain of the automotive semiconductors. That is why I am personally very, very excited about this particular sector. Yeah. All right. So without much further ado, let's start with a quick recap of what I have been sharing in the past two sessions. Now, I hope you remember this very interesting picture here. Basically, it is to show what is the emerging trend in the future, right? So I mentioned previously that 5G is the bedrock of all the future technologies, right? Because you remember I say that 5G is a little bit like the infrastructure, the highway, whereby you need to have the roads first before you can put the vehicles, right? Okay, so 5G is the enabler to a lot of future technologies, including IoT, industrial revolution 4.0, autonomous vehicles, so on and so forth. But what I did not mention previously is that along the way, these future technologies is slowly evolving, right? Automotive is always there. Okay, now what do I mean by that? Now, from what we have now, because there's still a lot of traditional cars on the road, right? From the traditional cars, we call it the ICE, the internal combustion engine cars, vehicles, to a fully electric vehicle, to a fully autonomous vehicle, right? It will take years, all right? It may take even decades to fully actualize this aspiration, right? That is why automotive electronics along the way will continue to evolve and become better. So this, if you're interested to park this investment thesis in your portfolio, right, it is going to be a long-term investment thesis. So it's not something that we will buy today and maybe just get out of the bandwagon a couple of months or a couple of years later. Personally, I believe that this is a long-term investment thesis, which is good at least for the next 10 to 20 years. Yeah. Okay. So now, I like to talk about, when I tell stories, I like to go back, way back to history, right? So before I talk about electronic vehicles, let's talk a bit about the train now. I'm not sure whether you have sat in a locomotive before, those with a steam engine, right? The steam engine was invented, I think, back in the 1800s by this person called George Stephenson. I hope that you still remember what you learned in primary school. Yeah, I still remember. There's this guy called George Stephenson who invented this thing called the rocket. His very first locomotive engine back in 1830, I think. Okay, so those were mostly steam power engine. Basically, you generate power by generating steam, and then you transfer you convert the steam into mechanical power. So that's basically it. Then eventually over time, as the technology advances, right, with the industrial revolution, we have the fully gas turbine locomotive. All right, not very popular, but they are. Then if we fast track to today, we've got the maglev, the magnetic levitation trains, very popular in countries like China, Shanghai, and Japan. And last but not least, these days you hear about Elon Musk, trying going for the Hyperloop, right? Now, as you can see, the revolution, the trend is going from steam to coal to some sort of fuel to now they have weaned themselves entirely of these fuel based systems to fully electrical systems. Now, if you think about it, it's a natural trend, right? Now, it is the same for cars. Vehicle cars, as we know, has also gone through a lot of changes over the years. But despite that, the car, the structure, the system is basically the same since 20, 30, 40 years ago when it first started out, right? So the trend is very simple. The car that that we normally know is actually the ICE. It's called the internal combustion engine. Okay. Then I'm sure that you heard of the hybrid car. Okay, the hybrid means it's a hybrid electric vehicle, meaning in the car there are two systems. There is one that is driven by the engine, and the other one that is driven by the motor, the fuel, the gas, sorry, the gasoline part as well as the electrical part. Then the ultimate goal is to have a fully battery operated battery electric vehicle. So this is called a BEV, meaning it's no more hybrid, no more engine. It's purely just a motor and electrical system driving the powertrain. Yeah. Now the trend is very interesting. As you can see here, I think this is a research by an institute. They measure the copper content by vehicle type. Now, previously, a typical ICE vehicle contained about 48 pounds of copper. Now, copper is a very important material to conduct electricity. I think you guys know this, right? So as the car is getting more and more electrified, naturally, the content of the copper in the car will increase as well. Okay, so from ICE to hybrid to battery electric vehicle, you can see that it will grow, multiply at least 4 times. All right, the copper content. So you can imagine the amount of electronics, the amount of electrical materials that is needed, to electrify the car. Now, this is why we are talking about this topic today. Then from there, we had to first of course take a look at what is driving, what are the governments around the world are doing to drive towards this vision. Yeah, I hope you can see this chart in front of me. It's a little bit, I don't know why, but it's a little bit blur. But basically, I just want to show that this is the chart of the greenhouse gas emission. All right, greenhouse gases basically includes the carbon dioxide, carbon monoxide, vapor, so on and so forth, that is generated because of heat, right? Now, energy is the biggest culprit here. It contributed more than 2/3 of the greenhouse gas effects globally, and out of which transportation contributes 16% of the greenhouse gases, out of which about 12% is generated from road transport. Now, when we say road transport, we are talking about vehicles, cars, passenger cars. We talk about vans, lorries, so on and so forth. Okay, but if you take a look at it, if we want to reduce the greenhouse gas emissions, right? You just compare the different categories in this chart, right? So we've got from the industries, iron and steel manufacturing. Do you think we can electrify this process? I don't think so personally, although I'm not a chemical engineer, because there are certain chemical reactions that you just require heat to catalyze those processes. Then we've got residential building heating, commercial systems, so on and so forth. These are a little bit tough for us to electrify, whether it is not practical or the technology is not here yet. But when it comes to road transport, our good old internal combustion engine, right? The technology is already there since many years ago. It's just that, do we have enough drive or motivation to really go towards this direction? Okay, and the answer is yes. I think the United Nations came out with this IPICC. Basically, it is a body to assess the science related to climate change. So during the Trump administration, this is a very shun off topic. Okay, hopefully with the Biden administration now, moving forward, the Americans would come back to the discussion table to seriously look at the effects of global warming and what we can do, to manage this situation. So the IPICC came out in 2018, came out with a report called the Global Warming SR15, which is following the Paris Agreement in 2015, right? So the key agenda of this report is to, first of all, is to stabilize the global temperature at 1.5 degrees above pre-industrial levels, meaning they're trying to bring the global temperature down by 1.5%. Now, although it looks very little, but it is a huge deal, yeah. A simple 1% change in global average global temperature can have a quite a devastating effect on the environment. And most importantly, they aim to achieve zero net greenhouse gas emissions by 2050. So remember this date. This is a very important date. I'll share with you why later. Yeah. Just to recap, they aspire to achieve net zero greenhouse effect by 2050. Now, net zero doesn't mean that there's no more greenhouse gas emissions. Just basically the creation as well is the management of the entire ecosystem. Okay. All right, and how do they aim to do that? By reducing by going to the low hanging fruit, which is the road transport. Okay. Uh, then what are the countries around the world doing towards this vision? As you can see on the right hand charts, the table on the right hand side. So this is from Thomson Reuters a couple of months ago. Countries like developed countries like China, France, Germany, especially the European countries, right? They're very, very upfront about this. Ireland, Netherlands, Norway, right? They're committed as soon as 2025 to be completely banning off the ICE vehicles. I think the country that is most, most active about this is Norway. In fact, 2025 is, I think, 4 years down the road, right? They're going to ban entirely the combustion engine vehicles on their roads. Okay, so I think most of the countries normally they'll target between 2030 to 2040, right? To absolutely ban these vehicles on their road. I think recently, just a couple of weeks ago, UK, the government decided to say, hey, they want to step up as well. So instead of waiting until 2040 or 2050, right, say, hey, we are going to ban all diesel engine cars by 2030, 10 years earlier than planned. And the hybrids can go another extra 5 years to 2035, beyond which all the cars should be electrified, right? Meaning they are pushing towards EV. Now, you can see that there is a lot of efforts around the world, right? Although now this table is not exhaustive. Of course, we are just highlighting the main examples here. But there is a concerted effort around the world, to actually push towards a greener mode of transportation, because it is low-hanging fruit, right? And we can see there's a lot of this capital being poured into this industry, a lot of grants given by government, a lot of tax incentives, to entice or to motivate industries to go towards this. All right. The chart on the top left, you can see that the EV share of annual vehicles, right, by 2030. So generally, on average, about 30% of the cars on the road will be electrified, meaning for every 10 cars, 3 will be an EV car by 2030, which is just 10 years down the road. By 2040, that ratio is going to go up to 50%, meaning for every 10 cars on the road, half of it will be electrified. So you can see that there is a serious effort, to push towards this agenda. Yeah. So now what does it mean to us? What does it mean to the industry, right? Especially to the electronics. Now, this is a slide that we took off from the Infineon Investor Relations, I think a couple months ago. This is a very interesting chart because they're comparing between hybrids and battery electric vehicle. Yeah, so they're not comparing between ICE to BEV, but basically between hybrids, could be plug-ins or fully plug-in, or just a typical battery hybrid to a fully battery operated electric vehicle. Now, one of the things I want to point out here is actually the red color chart. Where is my, okay, never mind. So I hope you can see my mouse. This is the power component, the power modules of the electric vehicle. Will be the jump from hybrid cars to battery electric vehicle is very huge, meaning Previously, maybe a typical hybrid car, the component for the power modules. Now, power includes voltage regulators, especially the high voltage regulators, semicon chipsets like ASIC chips. ASIC is the application specific ICs. All right. Now, these are the major components for the power systems. A hybrid car typically will have about $90 worth of power modules and systems in the car, but in a battery electric vehicle, it would jump to more than $300. So that's about at almost 3 times more. Yeah, so you can see how important this is. Now, other than the power, actually others is also very interesting. Others will include the opto meaning the LEDs, the display panels, the headlights, discrete as well as memory. Now, the more electrified your car, of course, the more processing you require, and then because of more processing, then you need a lot of memory, right, to drive the system. Okay, so this is basically to show you that automotive electrification requires higher semiconductor content. Now, next I want to talk a little bit about a very interesting topic. I think a lot of us know about autonomous vehicle already, meaning, wow, the car can drive on its own. In fact, you don't have to go too far. You can just go to Singapore. I heard, although I personally have not experienced, that you can hop on to is it Uber, or I think it should be Uber, that the Uber is driverless, yeah? So driverless means what? I don't know whether it's level 4 or level 5. Now, what is the meaning of all these levels, right, from level 0 to level 5 when it comes to autonomous vehicles? Okay, it's very simple. Okay, now level 0 means there's no autonomous features at all, meaning it's fully human operated. Level 1 is basically a driver assistance. Level 2, partial automation. Level 3, conditional automation. Then level 4, 5, full automation. Now, think of it this way. Level 1 is where you can have feet off, meaning, all right, you still need to be on the front seat. All right, you still need to have your hands on the wheels, on the what do you call it now? The wheels, but you do not have to put your feet on the brakes or on the pedals. Okay, basically the system will take care of itself. That's why we call it feet off for level 1. So let's go from the bottom of the body to the top. Level 2 means it's hands off, meaning you don't even have to have your hands on the steering wheel. The car will drive itself. They'll maneuver the roads and the curves and turnings, right? Now you still have to be in the driving seat just in case something happens and you need to take manual control, right? Then, okay, from feet off level 1 to level 2, hands off to level 3. So what's on top of your hands? It's basically your eyes. Level 3 means eyes off, meaning you can take your eyes off the road. The car will drive itself. Then it will be able to know how to avoid colliding with other objects or other vehicles on the road, so on and so forth, and so forth. Level 4 means brains off, meaning yes, you may still need to sit on the driver's seat, but you totally do not need to take care of the system at all. The car will drive on its own. You just need to set where you want to go. All right, just sit back and relax, and you arrive at your destination. Now, level 5 is the ultimate goal of autonomous vehicle. Is full automation, meaning, all right, the car do not even need to have a driver. So, can you imagine a fully automated car may not have brakes? They will not have gear shifts sticks. They will not even need to have a space for your driver, right? Because it's fully automated. Now that is why this is the autonomous vehicle paradigm will give rise to a lot of different new business model. Now imagine in the future, right? Yes, people still like to buy cars. They would like to own fancy cars like the Tesla Model S and so on and so forth, right? But imagine you sit in the morning, you wake up, you take a breakfast, then on the way to work, you sit in your car, which is fully automated, by the way. You can read the papers. Sorry, no more papers. You can read your mobile devices. You can schedule whatever you need to do for the day. Then when your car arrives to your destination, you don't even need to park the car, because once you get off, right, the car can go out on its own to earn money for you, whether through delivery or by picking passengers up to drive them. Now, this is what we call the mobility as a service, and it is something that is being discussed quite seriously about, and we believe that this will be the future for autonomous vehicle as well. Okay, very interesting times moving forward, right? So just now we talk about autonomous vehicles. So what does it mean? What do we need? What kind of systems or what kind of dependable systems are required? Again, this is the slide from Infineon. as mentioned here, you require a lot of systems for sensing, for computing, for communication, actuation meaning to translate electrical signal to mechanical action and vice versa. Dependable power supply system, memory, so on and so forth. So these will require a lot of semiconductor content. Yeah, and and of course, with higher semiconductor content, basically the bill of materials, okay, is going to increase. Again, I think this is a slide from Infineon as well. It shows the incremental average semiconductor content per car by level of automation over the number of years. So if I were to summarize, it's very simple. From level 2 to higher than level 2, the amount of in dollar terms, amount of semiconductor is going to grow about 85%, so almost doubling up from level 2, which is hands off. Sorry, yes, level 2 to level 3, or from hands off to eyes off. That will give rise to about 80%. Now, from level 2 or level 2 plus to level 4 and 5, where we have what's the word again? High automation to complete full automation, right? The semiconductor content in terms of dollar value will grow by 300%. So can you imagine the type of growth, the opportunities, right, in this space, over the number of years? As I mentioned before, this is not going to happen in the next couple of years. It's going to take years. It's going to take a lot of R&D efforts, a lot of collaborations among the market players to achieve this. Yeah. So that is why we believe that this is long-term investment thesis, right? Now, I hope up to now you can appreciate why I think in the first, excuse me, in the first installment of semiconductor, the future of semiconductor for the Bursa webinar series, right? We showed this chart whereby we highlighted, that in terms of global semiconductor billings projection for the future, right? The automotive segment has one of the highest growth, okay, compounded annual growth rate between 2019 to 2022. And we are quite confident that beyond 2022 to 2025 to 2030, right, the automotive segment will still enjoy very high growth for the global semiconductor billings, as I will show in the next few slides. Yeah. So I hope you guys follow so far. No more mathematical formula, I promise you. A lot of graphics, yeah. So we spent a lot of efforts to draw the graphics for you. Okay, so next time we're going to talk about the 3 growth automotive segments that we can focus on for investment opportunities. So there are actually a lot of different angles and different ways to look at it, but we simplified the 3 major segments. First is, of course, electrification, as I talk about. Secondly is the infotainment. May not be too obvious, but I think you guys can realize as well. If you buy a car today, whether it's a Proton X50, X70, or a BMW or a Volvo, right? Or even a Myvi, right? The dashboard is getting more and more cool, isn't it? Right? A lot of nice colors, LEDs, right? A lot of we call it infotainment system. The infotainment system will require a lot of display graphics and display panels. Then the third segment is basically autonomous mobility, which is a bit far into the future, right? But today, there's a lot of investment opportunities for the first two, the electrification as well as the infotainment of the automotive. Yeah. So what kind of semiconductor or electronic modules are required for each of these segments? Basically, for electrification, is obvious. You need to have very good power management system. All right, to convert power from AC to DC, DC to AC. You need to know how to isolate the electric signals, and you need to have a very, very good battery management system. All right, because the battery is, especially lithium ion, on its own is very volatile, so you need a very efficient and safe electronic system to manage this battery, right? The powertrain is also one of the most important modules in the electric car, right? So what are the semiconductor materials? The MOSFET, the metal oxide semiconductor is basically a transistor. Then we got other passive components like MLCC, the multi-layered ceramic capacitors, IGBT, also another type of transistors. It's called the insulated gate bipolar transistor. So basically transistors can do switching, can do passing of electric signal, and so on and so forth, right? For infotainment is a bit more interesting. They got sensors, they've got immersive audio processing, electronics. You got LCD display, noise cancellation. So for this, you need a lot of analog components. You need as well as discrete MEMS, as I mentioned. MEMS is the micro electronic mechanical systems, LEDs. Then of course for the autonomous vehicles, it's more advanced, so you need require a lot of very high-end electronics modules, like for navigation, for perception of the environment, and most importantly is for safety, right? So now when you talk about especially autonomous mobility, don't just think about hardware. In fact, the software or the algorithms that will actualize the autonomous mobility is far more important than the hardware itself. Okay. Now for that, of course, we need camera modules, we need radar systems, like lidar. Lidar stands for light detection and ranging. Basically, they use light for the system to sense what is in the surrounding. ADAS, it's called the Advanced Driverless Assistance Systems. Basically, it is to it is basically to take over the driver role in an autonomous vehicle. Okay, so I'm going to talk about these three, but the focus tonight is on electrification. I'm going to touch a little bit on infotainment as well as autonomous mobility later on, but I will focus a lot on electrification. Yeah. So in the electrification of vehicles, right, power electronics is obviously a very important component. There are various type of power modules, from ICs to the materials to the transistors, right? Your development estimated between 2019 to 2025, the power electronics market will grow about 4% per annum. Now, if you think about it, 4% per annum is not that great of a growth, right? But if you look at the details of the different intra segments of this power electronics, you will see that actually automotive, the powertrain, all right, is having a lot of a very high jump. So in 2019, the total addressable market is about 1.5 billion US dollar, which is very small, and it's going to grow at 1.9 billion. All right, then of course the electrical systems is also going to grow very huge. Okay, then we got the other, like the other transistors, modules, so on and so forth. Okay, now who are the players for these power modules? Okay, again, this is by Yole. Top on the list, this is the Taikor, the leader in the power electronics for automotive, especially, is actually Infineon Technologies. That's why you see that actually we use a lot of Infineon slides, to get the message across. Now, other than Infineon, then the next best, the second largest player is actually On Semiconductor. You realize that actually the revenue, the market share of On is almost half of Infineon Technologies, right? Then we've got other players like ST Micro, Vishay, Intel Technologies, also very famous, ROM, Toshiba, Diode, so on and so forth. Now, I just want to highlight that this is a power module market analysis, so it does not include the other things like chipset, sensors, so on and so forth. Yeah. So because we talk about electrification now, so these are the major players that we have to look out for. All right. So now, then other than that, basically this is just to show what are the major modules in an electric vehicle. Now, an electric vehicle is actually much more simpler than a traditional ICE car, the internal combustion engine, right? Basically, if you can understand that these 1, 2, 3, 4, 5 modules, right, is basically make the major components, the major modules that make up a electronic vehicle. We got the onboard charger. Basically, you need to transfer the energy from the battery, right, to actually drive the car. We got the HV load, the high voltage load, so that's why you need to isolate the voltage. We got the main drive, the powertrain will transfer the power generated from the battery to the entire car to drive the car around. Okay, then battery management. Now, in all these modules, all right, power components are very important. So power components could be from materials like silicon carbide, SiC. We talked about this extensively in a previous session. GaN, which is the gallium nitrate. Why this? Because SiC and GaN, compared to the traditional materials that we use, right, they can tolerate much higher power density, meaning they can actually deliver more power, all right, and they can tolerate more higher switching as well. Okay, and then we've got MOSFET IGBT. Okay, now this is a slide from on semiconductor. Why am I talking about this? Is because sorry, we've got another slide, yeah, before I give you the company. Yeah. Other than these transistors, power modules, actually, passive components also play a very important role. Now, in electronics, in semiconductor, I hope you still remember from the previous session, there are two major categories, the active as well as the passive. Active means the components, the electronics, the semiconductor will actually process something and produce something to impact another system or subsystem. Whereas passive, basically, may just pass through certain signal or isolate or even block. So in these passive components, which could consist of resistors, capacitors, so on and so forth, MLCC is one of the most widely used passive components in any electronic system. MLCC stands for multi-layer ceramic capacitor. Now, it's a very fancy name. Basically, it means a capacitor. Okay, excuse me. So these MLCCs are used in powertrains, used in the cases of the engine, used in the exterior like the headlights, the sliding windows, as well as the interior components like your GPS system, your LEDs, your door locks, power seats, so on and so forth, right? Now, to give you a little bit of context, so we've got this comparison by servos.com. Basically, they say that in a typical iPhone 6, which is launched in 2015, you've got an average about 500 MLCC components. So these MLCC components that shown in front of you, they've got about 500 of those in a tiny phone, right? In the iPhone X, because of the complexity that it can deliver, the features, right? The MLCC content actually double up to 1,000. Now you may be wondering, hey, if my electronic components double up, shouldn't the phone become thicker? But instead it becomes thinner. All right. Now this is the reason why MLCC is very useful, because as you can see from there are various sizes of the MLCC, from the very thick one to the very small one. The smaller it is, right, you need to miniaturize your devices, right? MLCC is even more important. Okay. Now, compared to a vehicle, a typical ICE vehicle, not even electric vehicle, has 2,500 MLCC in a car. Can you imagine that? 2.5 times higher than your iPhone X. Now, an electric vehicle like Tesla model has more than 10,000 MLCCs. Now, this is just a Tesla Model S and X. Can you imagine when the cars are more autonomous, right? The amount of this MLCC is going to have is going to be so huge. Okay. There was securities, I think back in 2019, they came out with a initiation coverage for this company called Murata. Now, Murata is the leader in MLCC component. They say that the number of capacitors, basically the MLCCs per vehicle, will rise as more and more electrical component content are being installed in the car. And they see that the momentum are likely to rise, and most importantly, the barriers of entry for MLCC market is very, very high. It means that you cannot simply just dump money to build an MLCC component plant next to Murata to compete with them. Not like gloves, yeah. Gloves basically is, as long as you have capital, right, you can basically build a factory tomorrow to compete with Top Glove or Supermax, yeah. But for Murata, the barrier entry is very high. And MLCCs are important passive components for powertrain, safety, and infotainment. Now, we also learned that there could be a potential shortage of MLCC and other passive components, so we've got to watch this space very carefully. All right, so now who are the major players? So just now we talk about, who are the global players. Then, of course, Malaysia as being an important semiconductor player in the supply chain. Actually, we have a lot of companies that actually supply to these IDMs, the independent device manufacturers as well. I remember that one of the questions from the previous session is that, somebody was asking, hey, David, how come you're not featuring Unisem, in your 5G? Okay, so I'm featuring to you now. Okay, just kidding lah. Unisem is actually a very important player when it comes to power electronics, because so you can see that yes, they are also known for 5G, but they are also an important player for automotive electronics. So they've got clients like Murata, Microsemi, Bosch, so on and so forth, who are actually major automotive players. So based on this is a snapshot from a CIMB, a recent CIMB report. As you can see, the major segments of Unisen's business is communications, which is where 5G is. So communication is a large chunk. Consumer devices is actually a large chunk as well. Both contributed more than 50%, but they've also got PC as well as industrial electronics and automotive. Okay, so automotive contribute about 20% or slightly more than less than 20% of their total revenue for Unisem. All right. Other than Unisem, again, when we talk about Unisem, we can't run away from talking about MPI as well, because they are a bit like Abang Adik, yeah. MPI also is a very important OSAT player in the automotive business. So they supply services especially as well as OSAT services to Infineon, to Bosch, to MS, to NXP, to Microsemi, Microchip, Texas Instruments, ST Micro, so on and so forth. These are all very big names in the automotive business. Okay, and in the latest presentation slide, they mentioned that they actually, they continue to invest hugely in the three segments, in Shenzhen for sensors, 5G testing, as well in Malaysia for MEMS and sensors, right? And the MEMS and sensors are meant for the automotive business. So unlike Unisem, MPI has a higher sales mix from automotive business. It's contributing about 30% of their revenue from the latest report. Yeah. So talk about two now. I'm going to spend a little bit more time to talk about one of the companies that I really like, which is PanaMaster. By the way, please remember my disclaimer. This is not a recommendation to buy this company. Basically, just sharing what I know. Yeah. So PanaMaster, I think we've also talked about PanaMaster in the previous two sessions. The segments that they service actually are 3D sensing for consumer for the devices, automotive as well as automation. Now, traditionally, telecommunications is PanaMaster's largest revenue contributor. So they are coming mostly from the the consumer devices, the infrastructure, wireless infrastructure like base stations. So they supply a lot of testing equipment and measurement systems for these industry players. Okay. Now, over the years, although telecommunication is very good business, but they're not as lucrative as the others like automotive or medical. Automotive and medical generally will give them better profit margins. So it is natural for the management to try, to diversify, to reduce the dependency from telecommunications to other segments like automotive. Now, as of the latest financial report, so automotive contributes about 14% of their total revenue. I believe they have intention to grow this part so that they will tone down the contribution for telecommunications and boost up the contributions for automotive and medical. Yeah, so that's why they put on a lot of capex into these segments. So in their suite of products, so under semiconductor and MEMS sensors, so they've got the test solutions, equipment and machines for discrete and ICs. This where we talk about power management system modules, power devices, power modules, motion sensors. So PanaMaster is actually quite an important player as well when it comes to automated testing equipment for the automotive segment. Yeah. And I think if you can get this from their website, they've got a suite of equipment that can do things from laser marking to pin insertion all the way to testing and final testing, right? Basically meaning for assembly to packaging for technologies for IGBT and power module solutions. Remember, IGBT is the isolated gate bipolar transistors, a very important component for the electrification of a vehicle. Okay, so in their clientele bit of clients, they've got Unisem, ASE Group, the largest OSAT player in the world. Knowles, TDK, also a very important power module player on semiconductor, and so on and so forth. Okay, now these are major power players, but of course AMS here is actually for sensors. Now you can see how important, how serious PanaMaster is. I believe that as long as they continue this path, they will enjoy as long as automotive electric electronics continue to grow, Pentamaster will grow as well. So I won't be surprised eventually that the automotive segment contribution will grow, and the telecommunication segment will actually reduce because of competition as well. Okay, so now other than the power management system, actually sensing is also a very important segment for electric vehicles, especially for the when we go from level 1, 2, 3 to level 4 and 5 of autonomous driving. Yeah, so in order for the vehicle or the machine to make sense of the surrounding and to know where to go, know what to avoid, right? They need to have a lot of sensors. Now, other than sensors, they also need to have a lot of cameras, radar system, so on and so forth, right? So one of the components that we have started studying since 2018 is this thing called the VICEL. VICEL stands for vertical surface cavity laser. All right, basically it is a compared to a radar system, it is infrared LED system. But you can just imagine that they can shoot very sharp, very precise this laser to the surface and reflect, so that they can actually process it and make it into a 3D graphic, just like what is shown on the top right. So this cylinder here is a typical LiDAR component that can be put on a car or around the car, and the output, all right, visually can look something like this. So it is a 360-degree sensing system, whereby the LiDAR system, LiDAR is still a hardware, so you still need a software to actually process and make sense of this, and to tell the vehicle how to react. Yeah? So as you can see here, basically they color code the output of the LiDAR system, so that they can recognize where are the humans. You got to absolutely avoid hitting the human, right? Then you got to avoid colliding with other vehicles as well as buildings. Okay, basically this is what LiDAR does. And who is the biggest, or who is one of the major VICEL supplier in the world? Is none other than MS. I talked about MS in the previous section as well. In fact, Pentamaster is not the only company that benefit from supply to MS. Yeah, so MS is they dub themselves as the leader in sensing technologies. Lately, they acquired Osram Opto as well. So they're moving into the Opto segment by acquiring Osram as well as Osram's clientele and network. From here, for the purpose of this webinar session, so MS actually is also a big player in autonomous driving and digital automotive lighting. So again, this is related to VICEL, and Pentamaster has a suite of testing test handlers and test measurement systems to actually cater for VICEL system as well, from wafer test handlers all the way to burn-in handlers, so on and so forth. Yeah. So as you can see, that actually Pentamaster is a pretty important player when it comes to power electronics for the automotive business. Okay. Now, this is a chart for Pentamaster since 2018 to now. If you have bought and invested in Pentamaster 2018, your investment will have grown around 5 times. That is excluding dividends. Yeah. All right. So congratulations if you are holding. I did not. I think I came on around. I was quite late in Pentamaster, probably in 2019 as well. Only. So the price, I think, on last week. So today I'm not sure about what's the price. It's about $5, which 5 ringgit, which translates to a market cap of about 3.5, 3.6 billion ringgit Malaysia. Now, I just want to reiterate that Pentamaster balance sheet is very strong. They're in net cash position. They are very profitable. The profit margin is more than 24%. Their growth, their top line, bottom line, and the operating cash flow growth has been tremendous over the past 3 years. Okay, the only problem with Pentamaster is the valuation. Now, the valuation, the P ratio is about 43 times. Well, if you see historical PE range, so historically in the past 3 years, they were ranging only between 15 times and 26 times, which means that 43 times they can be viewed, they can be can seem very over valued to you, to a typical investor, right? But if you look at if you study the latest quarterly report third quarter financial 2020, they actually gave a very good guidance moving forward. Now they did highlight that the third quarter was dragged down by the optical division, which is natural because all the opto players in Malaysia are hit because of the Osram merger with MS. A lot of things were being delayed. A lot of activities were not carried out, right? But we believe that the worst is over, and moving forward, a lot of activities are going to pick up. Now, Penang Master Management actually guided. Actually, they are very excited about the market potential of silicon carbide as well as gallium nitride. We mentioned about this, which are compound power semiconductors and power modules. All right, not just for automotive, but as well as for telecommunications like the 5G systems. Yeah. So I don't know, but personally, all right, again, it's not a recommendation. If you have a investment window of 3 to 5 years, right, I believe that Panda Master could be a good candidate for your portfolio if you want to go for investment thesis in automotive electronics. All right, so that's about Panda Master. Other than the electrification of vehicles, so I'm gonna be a little bit faster now because I've got 10 minutes to the hour before I open for Q&A. The next segment that I'm going to talk about after electrification of vehicles is actually automotive lighting and infotainment system. Okay, now this is also a very interesting segment that we should not neglect if you want to dab into the automotive electronics business. Now, the major contribution for automotive lighting is basically the headlamp and the rear lighting lamp. So basically your big lamps in the front as well as your brake lights and so off at the back, right? So now a lot of advanced materials are actually being is actually replacing traditional halogen lights or even xenon lights, right? Solid state lighting is a trend right now because they consume less power and they can actually illuminate much further and much wider angles. Okay, so this is some of statistics for you to see. Other than the exterior lighting, actually interior lighting is as like the LED panels on the dashboard is also very important. A Business Insider compiled a study. They are basically ask question to the study and say what are the more influence or what has more influence over your choice when you buy a new car. All right, so basically how we read this chart is towards the top is where the in-car technology is very important. Towards the bottom, the red color means the car driving performance has greater impact on my choice. It's basically like asking you now, when you buy a smartphone, right, what is your preference? What is more important to you? The camera function, how it looks, or what is inside, like how powerful it is, how much memory it has. Now, a lot of people, of course, will say, yeah, I want a smartphone which is a very good camera. I don't know how many megapixels now, and then it must, of course, look nice when they hold it, right? So it's the same for cars. It's very interesting to see that actually more than 50% of the respondents say that they are more interested. They are the in-car technology, which include the display, the infotainment system, has a bigger impact in their choice of cars. Okay, so that's very interesting. That which why we will look at this yeah. So in Malaysia, we've got quite a number of technology companies or semiconductor companies that supply to this segment. Okay, one of them is called Dominant Optoelectronics, D&O Technologies. Sorry, what's the full name? I can't remember. It's basically D&O. This company has almost everything in the automotive space. 97% of their revenue is for automotive business, and the rest is for others, right? So what do? They do a lot of infotainment system, the in-car dashboard. They have the smart RGBs. Okay, they've got interior illumination solutions, which has the speedometers, all your fancy gadgets, as well as your infotainment display panel. Now, other than that, they also have a range of exterior illumination products for the rear view as well as the headlamps. Okay. I think late recently, this particular segment is gaining a lot of traction, so that's why you see the share price is actually grown up quite a fair bit. Now, other than D&O, there's another company called JHM Consolidated. They are also very big in automotive lighting, but not how they are different from D&O is they are more diversified in a way that about two-thirds of their revenue is from automotive, about one-third is from industrial, and 1% is from aerospace. Okay, but they don't have much of interior lighting, but mostly for exterior illumination. And they've got who are their major customers. So they count Osram, Lumileds, and as well as MLS Automotive as their major customers for the automotive business. Okay. Um, sorry about that. What happened? Sorry about that. Okay, so that's about GHM. Now, as I mentioned, I won't touch too much on the infotainment system. I'm going to move next to the autonomous mobility because I think this is much more interesting. Now, for this segment, of course, one of the critical components is actually the MCU. Now, MCU stands for microcontroller units. Basically, it is a smart IC that has a very some basic components like processor unit, like a CPU. They've got memory. They've got communications interfaces like the buses as well as peripherals. So they have a very specific function. Each electronic module in a car, like the powertrain to cases, safety, infotainment, so on and so forth, will have their own sets of MCUs. It's like a mini CPU for your laptop. All right. So powertrain will have their own MCU, cases with their own MCU, so on and so forth. All right. Now in this, as you can see here, all the automotive component in the car will have MCU across the ranges. Yeah. Okay. Now, who are the major player in MCU? All right, as you can see on the bottom there. So just now we talk about a lot of power management ICs, power management modules. Now we talk about MCUs. Now in the space of MCU, NXP is a major player here, followed very closely by Renesas. All right, as well. Then of course Infineon is always there, right? So the top three players command about more than 60-70% of the market share. All right, Texas Instrument is the fourth largest, right? But the major names for the MCU is basically NXP and Renesas. Okay, now we have actually a company in Malaysia, all right, that actually counts NXP as one of the major customer. Now I know a lot of people are complaining, wait David, you always talk about companies like Pentamaster lah or Getronic lah that has gone, the share price has gone all the way to the top of the moon, right? So how can I invest, right? Now, so that's why I hear you. I give you a case study whereby the stock price has not gone up. In fact, has come down more than 50% in the past 3 years. This company is called KESM. They are a subsidiary of Sunlight, which is listed in Singapore. So they are also positioned to benefit from higher semiconductor component, especially when it comes to chipsets and MCUs. Okay, they claim, I think they are one of the largest independent burn-in service providers in the world. So let me see what's the time now. This is 8. Okay, I think I can spend a little bit more time to explain to you what the business model is about. Okay, so before I delve deeper, basically KESM, they cater for they also a major majority of the revenue actually comes from automotive system, automotive segment. That is why their business has not been doing very well because of the slowdown of automotive, especially in China. Again, because of trade war brought on by Trump. But which are the areas that they serve is basically the ADAS, safety, as well as infotainment. All right. Now, so what do they do? Now remember, for automotive electronics, actually the requirement is very, very stringent. Now, can you imagine if the requirement not stringent, then the component is not fail-safe? Imagine when you are driving on the road, suddenly your CPU will fry, or just your car will shut off by itself because of certain short circuit in your car, right? So in terms of challenges for electronic components, right, automotive has actually the highest requirement. Now, basically any electrical component, especially the chipsets and the MCUs, right? they need to go through rigorous testing to make sure that number one, they can be used for many years, and number two, they can withstand very adverse physical conditions like heat or this humidity or wear and tear. Now, how do they do that? They go through this process called burn-in testing. Basically, they burn, not not burned by fire, okay, but burned by electrical testing or even functional testing. So imagine that a small chip or MCU or IC like this, they will put into a casing, a socket like shown here. Now, of course, this is just one socket. They're not going to test each socket one at a time. It's going to take forever. What they do is they're going to build a large board. All right, it can be as huge as your arms extended. Now, each board will have a lot of these sockets lined up together. All right, in a lattice structure. Then you're going to place all these DUI called device under test, sorry, DUT, device under test, into these sockets. Then this board will be fit into an oven to do this burn-in testing. Now, one oven maybe can store in a few of these boards, so it basically you can do a lot of testing at one for many components at one shot. Okay, on the right hand side is basically just a sample of what a burn-in test result looks like. Okay, now why is this important for automotive electronics? If you compare consumer electronics to industrial electronics to automotive electronics, right, you can see that automotive electronics has the most stringent requirements in terms of temperature. Now, a consumer device, they are designed to withstand a temperature range difference of between 0 degrees to 40 degrees Celsius. But automotive, right, is made to withstand from negative 40 below freezing point to 160 degrees because of the proximity to the engine or the heat generating systems, right? So they got to be able to withstand such a huge range of different temperatures. The operating times, now your smartphones or your computers, right, after 2-3 years it's spoiled, then you say, yeah, okay, like expected, right? But our car cannot be like that. For automotive, right, the components need to, well, at least, they need to be reliable at least for up to 15 years. Okay, I mentioned about humidity as well. The tolerated failure rate is 0, not even 0.1%, not even 0.0001%. It's zero failure. Okay, so it's very stringent. Okay, so that is why burn-in testing services providers like KSM, right, they are actually very important for the automotive business. Okay, now as I mentioned, the share price has actually came down 70% since 2019, mainly thanks to Trump with his ongoing trade war with China. Then unfortunately in 2020, where it was supposed to pick up, then COVID-19 happened. Because a lot of countries, especially China, were in lockdown, right? So they can't sell cars, so it affects the entire automotive supply chain, including KSM. Now, KSM, in terms of market cap, they are pretty small player. Their market cap is less than 500 million. The price is $10. I think today also about $10. They just recently released their quarterly report. A lot of people are saying, wow, this company, no hope already, a good game, GG already. But we actually saw a lot of improvement in the operation, especially in the CAPEX program, and we are pretty excited about this business moving forward. They're in net cash position. Now, although you see that in the past 3 years, right, their revenue was slowing down at 12% per annum. The net profit was plunging at 86% per annum for the past 3 years. But if you look at the operating cash flow, the operating cash flow is growing at 3.5%. They're pretty solid, meaning despite their slowdown in revenue, despite their losses, right, in the bottom line, right, their operating cash flow is still very, pretty much business as usual. So we are just waiting to see, business should pick up, especially nowadays the automotive business is coming back. As you can see, I think even locally, right, they say that the Perodua sales Perodua and Proton sales are hitting the roof, yeah. So to conclude, to answer the question just now, which I posed myself, is it a rebound? Is a rebound on the horizon for automotive? You decide on your own. So I just simply present you the facts. Yeah. whether it's from North America to Europe to Greater China to Japan, Korea, the rest of the world, all right, you can see that yes, 2020 is basically a goner, it's a sunken case already. But if you look towards beyond 2020 to 2021, you will see that actually especially the light vehicle production is expected to grow, back to positive region. In North America this year, 2020, the vehicle production for the light vehicles is expected to plunge about 21%, but next year they're going to grow at positive 18%. Europe as well, China as well, Japan, rest of the world, and even Malaysia. That's why we see that actually new launches of the X50 as well as the new Myvis, right? The sales are very, very good. These are basically the light vehicle category. Yeah. So now with this, we believe that it is we are actually quite near to the turning point of automotive, that things should look better moving forward, notwithstanding further lockdowns, which we believe will not happen, notwithstanding any more geopolitical drama, especially between the two major powers, which is US and China. So as long as these are contained or managed, right, we believe that automotive business should come back and it should benefit a lot of these automotive electronic players that I just mentioned earlier on. Okay, so with that, I guess this is the end of my presentation. So it took about 66 minutes, 6 minutes more than the hour. So back to you, Shane. I hope you guys enjoyed my session tonight. Yeah, thank you.
Thank you so much, David, for your insightful and in-depth sharing on this automotive semiconductors futures. I guess by now, all of us here should be very familiar with the future trend and with the growth of from with the advent of the electric vehicles. From the cars were more mechanical in the past, but we are getting more electronic now. So with hopefully that the BEV, battery electric vehicle, will be available, sooner, so you can reduce all the carbon footprint. All right. So thank you so much, David, for your sharing.